let's solve this together. It says 6 raised to the power x is equal to 6x plus 24. We're required to solve for the values of x in this question, okay? Now, in order to solve this, the first thing we can do is to say 6 raised to the power x here can be written to be equal to, we can factorize 6 from here to become 6 into x plus 4, okay? Now at this point, you can say that let's divide both sides by 6, okay? So we have 6 striking 6, and here we have 6 raised to the power x divided by 6. If you recall from the laws of indices, when you say a raised to the power m divided by a raised to the power n, it's equal to a raised to the power m minus n. Applying this law here, we have 6 raised to the power x minus, this is invisible 1, so we put 1 here. So this is 1. 6 raised to the power x minus 1 is equal to, we have here to be x plus 4. Okay? Now at this point, we can say, let's now divide both sides by this. So we have this place divided by 6 raised to the power x minus 1, and here divided by 6 raised to the power x minus 1. So we have that 6 raised to the power x minus 1, so 6 raised to the power x minus 1, so that we have 1 to be equal to x plus 4 multiplied by. Now for this part, you can say that this is 6 raised to the power x minus 1. When inverted, you have 6 raised to the power minus whatever it's here, so minus x minus 1. Okay? Now this is now 1 to be equal to x plus 4 multiplied by 6 raised to the power what? So this is what? 1 minus x, alright? Because minus times minus is plus, okay? Moving on from here, we can say, let's transform this so that this will look alike. You see what I'm doing in a second. Then we have 1 to be equal to, so we have here to be 4 minus x, so 4 plus x rather, which is then as x plus 4, multiplied by 6 raised to the power 1 minus x, okay? Now I can say let's multiply both sides by minus 1. So we have minus 1 times 1 is minus 1 to be equal to minus times 4 minus x, as minus 4 minus x raised to the power 6 raised to the power 1 minus x, okay? Now, next thing we can do here, because the reasoning here is to make this number and this number the same, alright? The next thing we can do here is to say, let us subtract, if you subtract 5 from 1, it gives us minus 4, which is this, okay? So 1 is equal to 5 minus 4, okay? So if you subtract 5 from 1, we get minus 4. Now knowing this, we can say that how do we get minus 5 here? So that we subtract it from 1. The only way we can get it is to say that we can multiply both sides by minus 5. Now watch. I have minus 1 times 6 raised to the power now, minus 5. So we equal to minus 4 minus x. Remember this is inside brackets, please. Multiplied by 6 raised to the power. Okay, you have 1 minus x multiplied by 6 raised to the power negative 5. Okay? And this is 1 times this is the same thing as this, so we have negative 6 raised to the power negative 5, okay, on this side to be equal to, now we have minus 4 minus x, okay, multiplied by 6 raised to the power now. When you have multiplication, you add the powers. So we have 1 plus minus 5 to be what? Minus 4, and then we have minus x. Okay, now we've achieved a form of uniformity between what is on the base and what is in the power. Okay, now getting this, we can now apply the Lambert's W formula here. But wait, Lambert's W formula is simply a formula that states that when we have a number multiplied by e raised to the power of that same number, if we take the product log of this, which is called the W, which is where the Lambert's W formula is named from, it's equal to that number. Okay, so this number here might be x. So we have x e to the power of x, w of it is x, y e to the power of y, w of it is y. Okay, t e to the power of t, w of that is t, just like that. Now, sweet deal. We can now say, but we have 6 here. Okay, now let me show you something. When we have logarithm in base e, okay, of say 6 to be equal to y. Now we have that e raised to the power y is equal to 6. But what's our y? Our y should be logarithm of inverse e of 6, right? Now, we can replace this y now. This logarithm inverse e of 6 is a natural log of 6, so ln of 6. So we can say that e raised to the power ln of 6 is equal to 6. Alright? So knowing this now, we can now apply this and replace 6 with e raised to the power ln of 6 because it's the same thing as 6. Alright? Having achieved uniformity at both sides of e, both the power and the moment of multiplying e, we can now say let's take w of both sides. So if we take the w of the right hand side, okay, it is equal to the w of the left hand side. Alright? Now we can say that this becomes, okay, so we have here to still be w of bracket open negative ln of 6 divided by 6 over 5 brackets closed to be equal to w of this is now negative 4 minus x ln of 6. Okay, so this is multiplied. Now, from this point, you can say let's divide both sides by ln of 6. ln of 6 strikes ln of 6 here. So, and what you have here left is this place divided by ln of 6. So, lastly, we now have that our x is equal to, so we push this over to this side and push this over to this side. So, we have positive x now to be equal to, we have negative 4 minus w of bracket open negative ln of 6 divided by 6 over 5. Okay, now divided by ln of 6. Okay, so this becomes the final answer to this question. Now, to be able to get the exact number or exact value of this answer, you input this in the calculator known as Wolfram Alpha. Okay, so the Wolfram Alpha calculator tells you the exact value of this, okay, in decimal. All right. So thanks for watching. If you made it to the end, please like, comment, and subscribe. I'll see you guys in my next video.